So now the longer story about what I have modified on my 3D printer, which is Prusa. I'm Alexis, hacker, inventor and entrepreneur, and I try to make money out of this by building inventions. How do I improve my efficiency in building stuff? Several modifications I made. First, I'm down in the basement here. This one is my cable going up, out of the window, up and into the window again. So I have a LAN connection down here, which is nice to have. Wi-Fi would also work, but I wanted it wired. So I have everything connected, but we are in the basement here. And so if I want to have a quick look if my print is working as expected, I want a camera. I have an Octopi server, which is in a Raspberry Pi, which is right behind this beam, right? So that's where I have a Raspberry Pi with Octopi installed. Very good software. And Octopi allows me to directly upload stuff out of my slicer. It's just like upload and print. So that makes it very comfortable. So from my office up there, I design stuff, I slice, I upload and print. And I can, even from there, watch if my first layer adhesion is good, if the print is going well, can look from time to time without coming down all the time. So that is already a very useful thing. To make this possible, I also integrated some LED lights down here. So that gives me light, even if everything down here is dark. Because usually, of course, I turn off all the lights down here when I'm not down here, saving energy, you know? So that's why I also integrated the lights. These are simple LED strips. Actually, it's 12 volt strips, but I took 2 of them in series so I can power them with 24 volts. And I hooked all that up to the 24 volts that come out of the power supply of the Prusa. This few milliamps don't hurt anyone, so it works well. Originally, I had the multi-material upgrade, but I didn't like that. It didn't really work. But I used the power that I still had connected for the multi-material to fork some juice to get it for the LED lights. Now, to power the Raspberry Pi, I have this little power supply up here, which is plugged into this box. Coming into this box, I come with mains power, of course. Oh my goodness, that cable is a bit loose. I'm scared. Because I'm scared because this is a over 1 day print. This will take about 30 hours to print, so it would be bad if it failed. I have this little box, and electricity comes in, has a permanent on outlet for that little 5 volt power supply that powers the Raspberry Pi with Octoprint installed. But then it also has a solid state relay. One of these things are great. It's the simplest way to control high power from a Raspberry Pi. You get them for $4 to $5 on AliExpress or somewhere. And this thing can switch up to 10 amps, 230 volts with an input of 3 volts. And since your Raspberry Pi has 3 volts, you can connect one of the GPIO pins. This is actually this little brown and yellow wire I have here that goes down onto this. So Octoprint, actually there is an Octoprint plugin for the Raspberry Pi GPIOs and a second plugin to control power supply. I have these plugins installed on Octoprint, and so that allows me to control the whole printer via Octoprint. And I have set my settings that at the end of a print after 10 minutes, it shuts everything down. Except the Raspberry Pi, of course. That's a server that's running 24/7. But at least I have the whole rest of the machine powered down, which gives me additional safety, helps me save a bit energy. So, and that plugin also automatically starts the printer as soon as a new print job comes in. But then the print job, I haven't got yet to start printing automatically because it takes about 1 second or 2 for the Octoprint to detect the serial connection, the USB connection. And so that's why I have to start printing manually. But it's just like uploading, wait a second, start print in my Octopi, and and then it starts printing. So, and the Raspberry Pi, yeah, gets his 5 volts over USB here, and has on the other end a USB cable going out to the Prusa, and so it can stream the data to the Prusa for printing. Octopi is amazing, works perfectly. Now, since the light is connected to the power supply of the Prusa, as soon as I turn off the main power of the Prusa, the light goes off also. And as soon as I start it, I turn the light on, and then I can look what happens. And that's also a good indicator, because then in my video stream, I can just look, oh, it's dark, that means the print is finished. And just to have a bit more of an idea what's going on, I had actually a second cheap webcam lying around, which I put down here. So it's looking horizontally at the print. Maybe I realign a bit. So it's looking into the print, so I see how high the print is and how well it goes. And that's also an option you can activate in Octoprint. You will find tutorials online. I will link them down below. A tutorial for dual cam Octoprint, which is very useful, because then I can switch and can look how high is my print already to get a bit an idea and check if everything is fine, or if I really have to come down and cancel the print to restart it. Except for that, what you don't see is I have a little silicone sock. I have this little silicone thing around my nozzle, around my heat block, which has the advantage that plastic doesn't stick to it, so it's more or less non-stick, and it gives you a little bit more isolation, so it protects from heat loss, so you have a bit more stable temperature, but I'm not sure if it makes really sense. I don't really notice a difference, but I just got them together with the filament. Now that's the last and biggest mod. This originally was an 8 kilogram spool of filament. Now it's probably down to 1 kilogram or so, which has the advantage that I just print and don't think about it. I print stuff to build machines, so I don't care what color. So it's black. It's black, black or black. It's always black. And I used some ball bearings up here to have a little friction so that the extruder can pull that wire. And after I did that, I realized you need a slight bit of friction, because if not, every time you move quickly, you will pull quickly on that roll, and it will rotate and keep rotating for a while, and then you get a mess with the filament. You don't want to unspool filament without printing, or it crosses over and it tangles, and then you have an issue. So that's why I added this thing here. It's some silicone rubber, but a piece of cloth or whatever would also do it, that lies on top of the roll and has two features. First, it does a little bit of friction, so the roll is not continuously rotating if you give it a sharp pull. But the second thing is it covers the whole roll over there, so even if it unrolls a bit, the filament will not jump over these borders, right? Because that's what happened in the first version I had. It started unrolling, it fell down here, and you can imagine that if you have 3 turns of filament around here, then it jams and then you get lost. So that's the reason why I have this on top. And yeah, that's basically it. I mean, I 3D printed some little wheels to go on the ball bearings that have an edge on the end. So even if I'm slightly inclined, the spool will not move out of these rollers. And so that's perfect. It guides it in this direction, and it has low friction in this direction. And yeah, I mean, I'm nearly through an 8 kilogram roll, so that's probably a week of printing continuously, and that works perfectly. So to summarize, what have I done? Second camera down here, first camera up here, LED lights, Raspberry Pi with Octopi, Raspberry Pi controlling a solid state relay that switches on main power, auxiliary power from a 5 volt smartphone power supply for the Raspberry Pi, and the big spool with the silicone sheet on top. And that's my setup, and it's been printing for months now, and I'm very happy. Check out my channel to see what is the stuff I'm printing with that machine, because I'm building whole machines 3D printed, like the peristaltic pump you might have seen in another video. I print big stuff like this peristaltic pump rotor with integrated belt pulley. I print stuff like this on that machine, and it's really strong. I forgot to mention, I always print in PETG. I started with PETG, stuck to it, and I'm very happy. No fiber reinforcement or so, just plain PETG for my prints.